Alright, so good morning, all of you. Known as motion, okay, and it's a part of physics, right? So we will discuss about the motion only, okay, for class 9th. Okay, all right. So let's begin with this chapter. So if you think about the motion of any object, so what the first term clicked in your mind? Can you guess? No. Okay. So there is a term called position, where there is a term. One of the term is called position. What does position means? So if we talk about my position, so I am just standing before the whiteboard. Okay, you can say the 10 centimeter after the board, right? That's my position. Okay, so position is what? It's just a, you can say, a location of a body, but existing at any place. Okay, all right. So the position changes. Okay, so let's say I'm here. Standing in like Mokama, and after some time we reach to the Patna. Okay, so after what? After 1 hour, okay, we will here. Okay, before 1 hour, my initial position is this. You can say A and B. So A is, wait, no need to write. So my initial position was in Mukama, okay, and my final position was in like Patna. Okay, so as you can see, the position changes time to time. Okay, all right. Now another term is, as you can see already, the change of position. We have already seen with this example that, for instance, I was in Mukama, and after 1 hour I was in Patna. So the position changes from Mukama to Patna. Okay, this is what change in position means. Okay. Now the term comes as the motion. Okay. Now you can define the motion. So motion is nothing but what? Motion is nothing but change of position from one point to other with a fixed reference point. Okay, so let's understand with this statement what this statement tells us. Okay, so the change of position, okay, the change of position from one point to other, from one point to other, or you can see from initial point to the final position. Okay, with a fixed reference point. What does the reference point means? So the reference point means one of the person is standing over here, okay, and he is just informing us that he is informing like me that I was in Mukama initially, and after some time I was in Patna. Okay, so this person is the reference point. Okay, if we talk about the non-living subjects, so my reference point is like you can see in the, I think we all use the GPS. Okay, so in the map there we put the initial point and from where to where we have to go. Okay, and then we put the location where we have to reach. Okay, so our reference point is fixed. Okay, with that point, like we have to go to the Delhi, we have to go to the Patna. So my reference point, let's say here, Mukama, and from Mukama we are traveling to Patna, we are traveling to Delhi, we are traveling to Kolkata, we are traveling to Chennai. Okay, so the reference point is fixed. Okay, so I hope you understand that why the reference point is important, right? So the motion is the change of position from one point to other with a fixed reference point. Okay, I hope you are clear with this motion term. Okay, now moving on. Okay, so the location we already did. Okay, now, okay, so the reference point that the market is like 500 meter ahead from my place. Okay, so the place is the reference, and we are just telling that the market is located at the some distance. Okay, so all right, now, so what does the change of position mean? So okay, what is position? Did you get that? What is position? Position is the location, right? And when we travel from one point to other point, it is some distances. Okay, some path is covered, right? So let's say 100 kilometer. Okay, so from Mukama to Patna, what is the path covered? How much path is covered? It's 100 kilometer. Okay, in what? 1 hour. Okay, so this is the path, and path is referred as what? The distance also. Okay, so the path traveled in a given time is known as distance, right? Now, similarly, there is a term called speed, as you all have heard. What does the speed mean? Speed is what? Nothing but, as you know the formula, it's a distance upon time. means what? Means a path traveled in a given interval of time. Okay, so a speed is what? The distance or the path traveled in a given interval of time. So if we talk about this example, what is the speed over here? So speed is what? Nothing but what? The distance travels. So what is the distance over here? 100 kilometer. And the time we have taken is 1 hour. So we can say that the 100 kilometer per hour is the speed. Okay? For that object. Okay? Needs to be this much speed so that it can reach to Patna. Okay. Are you clear with that statement? Alright. So just have a look for a second. Alright. So as we have discussed the distance. Okay. There is a term known as displacement. Displacement. How these two terms are different from each other. Okay. So for this, you all have heard about the vector term. Okay. Sorry, we may not have heard about that also. So let's forget that. Let's understand this term. Okay. So the distance and travel, displacement. Okay. So displacement, what we have discussed is that it's a total path, or you can say total path traveled. Right? But similarly, the displacement is what? The shortest path or distance. Okay. Let's see how. Travel in like some time. Okay. So in a fixed so okay, let's have an example. So let's say there is a, you can say the bus, right? So the bus traveling from let's say that this point A. Okay, let's forget. Again, this is called Mokama. Same example I'm taking. Mokama, and this is the Patna. Okay. So from this point, the bus travels and reach to Patna. Okay. Reach to the Patna. Okay. And so the distance from Mokama to Patna is 100 kilometers. This is the distance. Because this is the total path traveled from Mokama to Patna. Okay? Alright. Now similarly, if we talk about displacement, so what is the displacement over here? What is the displacement? So displacement says that it's the shortest path. Shortest path means it travels from initial position to the final position. This is called as initial position. And this is the final position. Okay. So this is what 0 again, and this is what 100. Okay, 100 kilometer travel. Okay. So as we have discussed, the distance is traveled from this to this is 100 kilometer. And similarly, if we talk about displacement, displacement is what? The shortest path. The shortest path means what? The total path travel, the final position minus what? The initial position. Okay. So let's say the final one is 100 minus 0, and see, it is also giving the same as the distance. Okay. So, alright. So we can say that distance is a type of displacement, right? But the distance is not a type of distance, right? So let's see how. Because from this example we have seen that the distance and displacement having the same answers from here. Okay, so let's understand like how the displacement is different. So if you talk about like someone says to you that you go to the school, right? So let's say somebody asked you to go to the school. Yes, you always go to the school and you come back to the home. So if we talk about the displacement, so in that case, let's see how. So someone says that you start from home. You'll always start from home, sorry. Okay. So you start from home and you reach to the school. Okay. And it's let's say it's like what, 5 kilometers. Okay. So from home to school you're going, and that's a distance 5 kilometers. But this is mentioned. You go to the school and again you come back to the school. Okay. Okay. So the home is your final position, right? The home here is the initial. This point is the initial position, and this is the final position. Okay. So if we start with this 0 to 5, okay, 0 to 5 and 5 to 0. Okay. So in this case, if you see carefully, initial minus this, 0 minus 0. This here you get the 0 displacement, right? 0 kilometer. Okay. See how this is different, right? So here, and if we talk about, this is a what? Displacement. Displacement. Okay. This is also 5, right? But if we talk about distance, it's a total path, right? So starting from here, 5, and again here to here is 5. So this is what? 5 plus 5, which is 10 kilometer is the total path, right? Which is distance. Okay. So did you get that? How the distance is different from displacement, right? Alright, just have a look for a second. Okay, so our final point is there are basically two types of motion. Okay? One is uniform motion, and the second one is non. Okay. All right. So what is non-uniform motion? Let's understand what is uniform and non-uniform motion. Okay. So if we talk about uniform motion, so the uniform motion is what? When object travels a distance in equal interval of time. Okay? Now, as opposite to the uniform motion, when object travels unequal distance in equal interval of time. Okay? Alright. So uniform motion is the motion when the object travels equal distance in equal interval of time, whereas in non-uniform motion, when object is travel unequal distance in equal interval of time, so the body or the object is said to be in non-uniform motion. Okay. All right. So let's understand how. So the object travels equal distance. So let's say, okay, let's say any object at the ball. Okay. So for some region, it travels a distance from here, A point to B point. It covers at you can say 1 sec. Similarly, from B to C, in 1 second only, comes to B, C. Similarly, C to D, D to E. Okay, 1 second, 1 second. Alright. So you can see this is a equal distance. This is what we can say 1 kilometer. 1 kilometer. 1 kilometer. 1 kilometer. This is the equal distance travel in equal interval of time. Okay. Alright. So if we talk about the total distance 1, 2, 3, 4. So it's a 4 kilometer in what? 1, 2, 3, 4. 4 seconds. Okay. So this is what the constant. Okay. This goes on equal interval with equal distance. Okay. Okay. Alright. If we talk about non-uniform motion, similar example we'll take. Let's say the ball. Same ball. And comes here, it comes here, it comes here. Okay. It's what 1 second, 1 second, and 1 second. Okay. A, B, C, D. Okay. So let's say the ball is pushed, and let's say it covers 1 kilometer distance. And now in the same time, it covers 2 kilometers, and same time after that it covers 1 kilometer. Okay. So here you can see it's an unequal distance in equal interval of time. I'll take 1 second. After 1 second, it travels 1 kilometer, and then it travels 2 kilometers, and then again it travels 1 kilometer, and then maybe change to 10 kilometers, and so on. So this is what the unequal distance travel in equal intervals of time. Okay. So I hope you are clear with this statement and the example of it. Just have a look for a second. Right. So today this much is enough. I think. In the next class we'll see the speed, average speed, acceleration, and 2-3 more physical quantities, and also we'll see these all points through graphical representation of, you can say that, velocity time graph, acceleration time graph, or distance time graph. So keep watching my channel. Okay, thank you so much.